Hello and welcome to Chemistry with Lisa. Here we simplify chemistry for you just to make you understand and boost your grades in chemistry. Today we have an exciting topic to discuss on particulate nature of matter. What is matter? Matter is anything that has weight and occupies space. Like me, like you too. We all have weight and we occupy space. That is matter. Now, every matter is made up of three things: atoms, molecules, or ion. So, what is an atom? It is the smallest particle of an element which can take part in a chemical reaction. An atom can take part in a chemical reaction. Examples of atoms include oxygen atom, fluorine atom, chlorine atom, sodium atom, aluminum atom, etc. Then we look at a molecule. A molecule is the smallest particle of a substance that can normally exist alone and can still retain the chemical properties of that substance. A molecule retains the chemical property of that substance. Example of a molecule is oxygen molecule. You can also define a molecule as group of atoms that come together to form a molecule. Look up here, this is oxygen atom. Here, two oxygen atom makes up one molecule. Another example is chlorine. This is chlorine atom. Sorry, this is chlorine molecule. Two chlorine atom make up a molecule. Are we together? So this is a molecule and this is an atom. This is a molecule, this is an atom. Now this is diatom, meaning that it has two atoms. This is also diatom. This is triatomic. Then you have this is tetraatomic or polyatomic, as the case may be. Combination of two or more atoms combined together will give you molecule. Then we also have an ion. It is any atom or group of atom which is charged. Once you have a charged atom, you call it an ion. Charge means that it has positive or negative ions. Charge means that it is positively or negatively charged. So for example, oxygen, you have this oxygen ion, it is charged. You have chlorine, you have chlorine ion, it is charged. You have aluminium ion, it is charged. So once there is plus or minus attached to it, we call it an ion. Okay, so let's look at Dalton atomic theory. Now, Dalton was a scientist that proposed the atomic theory. Now, let's look at the things he proposed. Basically, some of the things he proposed were not really true because of discovery of other things. So let's look at the things he proposed. Now, he proposed that all elements are made up of small indivisible particles called atoms. But it was later discovered that that statement is not true. Why? Because it was discovered by Rutherford that atoms contain other subparticles known as proton, neutron, and electron. Now, Dalton also proposed that atoms can neither be created nor destroyed. It was modified because of the evidence of radioactivity. This statement is only true for ordinary chemical reactions, but not true for radioactivity. Then Dalton said that atoms of the same element are alike in every aspect and differ from atoms of all other elements. It has been modified due to the evidence of what? Isotopes. Now, isotopes, they have the same atomic number or the same number of proton but different number of neutron. Then Dalton also said that when atoms combine with other atoms, they do so in simple ratio. It has also been modified that this reaction or combination only take place in inorganic chemistry. When you come to organic, it doesn't take place. You have massive number of compounds, atoms of or molecules of compounds reacting together. So these have been modified due to the presence of organic compounds. let's move to the symbols we have in chemistry. Okay, so let's look at the first 20 elements and their symbols. Now, it is very important you know this offhand because it is going to help you in inorganic chemistry. And it is also important you know their numbers because their numbers talks about their atomic number, which will help you a lot in inorganic chemistry. So let's go. This is hydrogen. It is represented with a capital letter H. Helium, capital letter H, small letter E, not capital letter E. In fact, all the symbols must always begin with a capital letter. For those of them that have two letters, the first must be capital, the second one must be small letter. So helium is capital letter H, small e. Lithium, capital letter L, small I. Beryllium, capital letter B, small e. Boron, carbon, nitrogen, oxygen, fluorine, neon, capital letter N, small e. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Now, I have a little way of, making students remember these first 20 elements with a song. You can also incorporate it if you wish. Listen to it. It says, hydrogen, helium, lithium, barium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. I don't know if you like it, but with this, it always helps students to retain the first 20 elements offhand. Okay, so let's move in to the next topic. Okay, so let's look at the relative molecular mass. Relative molecular mass is the number of times the average mass of one molecule of an atom is heavier than 1/12 the mass of one atom of carbon 12. The number of time an average mass of one molecule of a substance is heavier than 1/12 the mass of one atom of carbon 12. That is what we refer to as relative molecular mass. Now, examiner is going to ask you some questions on calculation of the relative molecular mass. It is very simple. So look at this question. Calculate the relative molecular mass of calcium triazocarbonate 4. It is very simple. So what do? Calcium is 40 plus carbon is 12 plus oxygen. This 3 is only for oxygen. So you put in brackets 3 times oxygen is what? 16. So this would be 40 plus 12 plus this times this 48. When you add up, you have 100. Please, relative molecular mass does not have a unit. Take note. Let's look at this other question here. Now, this 2 belongs to aluminium only. So it will be 2 times aluminium is 27. Put it in brackets plus sulfur. Sulfur, okay, we are not giving sulfur here, but sulfur is 32. So sulfur is 32 plus 4 belongs to oxygen only. So 4 times oxygen is what? 16. Now there is a dot here. So please put that dot too. Dot, there is 5. Now this 5 is affecting everybody. Everybody here is sharing this 5. Are we together? Everybody here is sharing this 5, but this 2 is being shared by hydrogen only. So what will it be? 5 into hydrogen is what? 2 times hydrogen is 1 plus oxygen is what? 16. Are we together? So let's solve. This times this will give us 54 plus 32 plus this times this 64 dot 5 into this times this plus 16. So this will be 54 plus 32 plus 64 point dot this plus this 18. So 54 plus 32 plus 64 plus 5 times this will give us what? 90. So we have 90 here. So we are going to add up. Now the reason why I asked you to put this here so that in your solving, you're not going to make a mistake. So now we can confidently convert it to plus. So let's add up. What will it be? 54 plus 32 plus 64 plus 90. That will give us 240. So the relative molecular mass of this is 240. Remember, relative molecular mass has no units. Isn't this simple? Okay, so we move over to valency. What is valency? Valency is the combining power of an element. The combining power of an element is what we refer to as valency. Now, in your examination, in your examination, you'll be expected to solve questions under valency. But first of all, let's find out how you discover your valency. How do you find your valency? I want to share a little secret with you. Now, to find the valency, you consider elements that have 3 electrons in the outermost shell. 1, 2, 3 electrons in the outermost shell. That will be their valency. But elements that have more than 3 in the outermost shell, the number it requires to complete will be their valency. So let's look at this. Now, sodium, the atomic number of sodium is 11. So let's draw sodium. Now the first shell can only accommodate 2 electrons. Then the other shells can accommodate 8 electrons. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's now 8, 11. Are we together? So it has 1 electron in the outermost shell. So what will be the valency? 1. If it had 2 electrons in the outermost shell, 2. 3 electrons in the outermost shell, 3. But when it is more than 3 in the outermost shell, you ask yourself, how many does it need to make up to 8? That would be the valency. Now let's look at fluorine. Fluorine is atomic number is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many electrons are in the outermost shell? 1, 2, 3, 4, 5, 6, 7. 7 is in the outermost shell. That means how many does it need to make up to the 8? 1. So what will be the valency? 1. Isn't that simple? Now, the examiner may ask you, what is the formula of the compound form? All you need to do is to cross multiply. So what's the formula of the compound form? The formula of the compound form is sodium fluoride. Let me give you another example. Okay, so let's look at this. Let's find the valency and the formula of the compound formed. Now, aluminium is 13. So let's draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 8 complete. 11, 12, 13. Remember, 1, 2, 3 in the outermost shell is the valency. If it's more than that, you ask yourself, how many does it need to complete to 8? So let's draw it. 1, 2, 3, 4, 5, 6, 7, 8. Now the outermost shell is 6. 1, 2, 3, 4, 5, 6. So how many does it need to make up to 8? 2. So what will be the valency of this person? It has 3 in the outermost shell. What will be the valency? 3. Then this person has more than 3. It has 6. How many does it need to complete to the 8? 2. So what do? You cross multiply. So aluminium will be aluminium 2, oxygen will be oxygen 3. This is the formula of the compound form. It is aluminium oxide. Isn't that simple? Let's move over to the balancing of equation. Okay, so let's move over to balancing of equation. Now, in balancing of equation, I don't need to give you all the long method. I just want to use the short method to teach you how quickly you can balance equation. It's very simple. Now, let's look at this. In balancing of equation, the only place you can attach numbers are here, here, okay, this is plus, here, 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 here. That's the only place you can attach numbers. We call it the superscript. On no occasion should you ever attach number here, or you come to hydrogen and attach, or you come here and attach. No. Once the equation has been given, the only way you can add number is by adding your superscript If you add number here, it is wrong. We call it the subscript. You have no business with subscripts. So let's balance this equation. Magnesium is 1, magnesium is 1. Hydrogen is 1, hydrogen is 2. So since it is 2, we add 2 here to balance. Hydrogen is now balanced. So you have these 2 now is affecting everything here. It's not only affecting hydrogen, these 2 is affecting everything here. So 2 hydrogen, this hydrogen, 2 hydrogen. Then 2 chlorine, 2 chlorine, it is balanced. Then we move to the next one. Potassium is 1, potassium is 1. Chlorine is 1, chlorine is 1. Oxygen is 3, oxygen is 2. So what do? Let's add 2 here. 2 times 2, 4. If we also add 2 here, 2 times 3. This 3 is only affecting oxygen only, but this 2 is affecting all of them. So 2 times 3 will give us 6 oxygen. 2 times 2 will give us 4. So it's not balanced. So let's add 3 here. 3 times 2, 6. 2 times 3, 6. So oxygen is balanced. Now, after balancing, you rebalance again to make sure that everything is balanced. 2 potassium, 1 potassium. So it's not balanced. We add another 2 here. So 2 potassium, 2 potassium. 2 chlorine, 2 chlorine. 2 times 3, 6 oxygen. 3 times 2, 6 oxygen. It is balanced. Okay, so I would like you to try this. Try and balance it and give me your answer in the comment section. Okay, so we move over to the question, set of questions you need to answer. So this is the first set of questions you need to answer. Answer this question and drop your answer in the comment section. Okay, these are called out from past questions. So let's answer them. We look at question 1. This is X, Y, Z, Q are subscripts that you need to add. So let's balance the equation. First thing, let's clean up this so that we can have enough space to write our superscripts effectively. Now, nitrogen is 1, nitrogen is 1. Hydrogen is 3, hydrogen is 2. So what do? Let's say we add 2 here. Then if we add 2 here, it will be 2 times 2, 4. Then hydrogen here is 3, it's still not balanced. So if we add 2 here, 2 times 3 is 6. So let's make this guy. Let's add 3 here so that it will be 6. 3 times 2, 6, it is balanced. Then, so 2, remember this 2 is affecting everything. So 2 nitrogen, 2 nitrogen, 1 nitrogen. So we add 2 again here. So 2 nitrogen, 2 nitrogen. 2 times 3 is 6 hydrogen, 3 times 2 is 6 hydrogen. Then oxygen, 2 oxygen. This 2 is affecting everything here. 2 oxygen. It is balanced. So the values are 2, 1, 2, 3. Simple. The second question says the atomicity of ozone is, what is atomicity? The number of atoms present in a substance or in a compound or in a molecule. So ozone, you represent ozone like this. This is ozone. So what is the atomicity? It is triatomic. Triatomic. Triatomic means it has 3 atoms. Diatomic means 2. Tri means 3. Tetraatomic means 4. Pentaatomic means 5. And so on and so forth. Calculate the relative molecular mass of magnesium hydroxide and lead triosonitrate 5. It is very simple. So let's solve. You have magnesium hydroxide. Remember, this 2 is affecting everything in the bracket. So magnesium is what? Magnesium is 24. 24 plus. This 2 is affecting everything in the bracket. So you say 2 into oxygen is what? 16 plus hydrogen. Hydrogen is 1. So you have that 24 plus 2 into 16 plus 1, 17. So 24 plus 2 times 17, 34. When you add up 2 plus 2, 8. This plus this 5, 58 is the answer. Now, I want you to solve that of lead 2 triosonitrate 5. Remember that this 3 now, this 3 here is only owned by the oxygen. And this two here is owned by all of them in the bracket. So I would like to have your answer in the comment section. Okay, so we come to the end of this particular class. Please do well to subscribe to our channel if you find this video very helpful. And also encourage your friends, share and send to your friends and encourage them to watch. We want to make sure that you pass in your forthcoming examination. Thank you and success in your exam. Bye.